In the annals of aviation history, the genesis of the Micro stands out as a daring venture that can be traced all the way back to the transformative year of 1967. It was during this time that Jim Bede, a visionary in the world of aeronautics, found himself captivated and inspired by the sleek and sophisticated design of the Schleicher ASW 15. Teaming up with his lead designer, Paul Griffin, the duo embarked on an exhilarating journey to sketch out the preliminary designs of what would eventually materialize as the BD-5. However, it is crucial to note that during this period, Bede's attention was also divided as he was deeply involved in the development of the Bede BD-4. The year 1970 marked a pivotal moment in the history of the Micro, as serious and committed efforts began to breathe life into this groundbreaking project. The construction of the prototype commenced with fervour and intensity as the year progressed. The Micro was poised to defy conventions and set a new standard in aircraft design. Unlike the fairly traditional BD-4, the Micro emerged as a radical innovation. It was an incredibly compact one-seat design, resembling a jet fighter more than a typical aircraft used in general aviation. The pilot was enveloped in a semi-reclined position under a massive fighter-like plexiglass canopy, just inches above their head. Positioned directly behind the cockpit was a compartment, meticulously engineered to house a powerful two-cylinder air-cooled 40-horsepower piston engine, driving a pusher propeller with precision. In a relentless pursuit of superior performance, the aircraft was equipped with a V-tail and retractable landing gear, serving the dual purpose of minimizing drag and maximizing efficiency. The drag was so phenomenally low that the introduction of split flaps and spoilers became necessary, integrated into the wing to enhance deceleration during landing phases. This innovative application marked a historic first for light aircraft. The Micro, with its low drag, promised an exhilarating performance. Powered by the 40-horsepower engine, it was poised to reach speeds nearly touching 200 miles per hour. Elevating the stakes, the larger 55-horsepower engine allowed for a comfortable cruising speed of 200 miles per hour, paired with a remarkable range of 1,215 miles when equipped with a 21-foot 6-inch B-wing. For those seeking thrills and aerial acrobatics, the shorter A-wing, measuring 14 feet 3 inches, offered a fully aerobatic experience and a tantalizingly higher top speed. For the enthusiasts and builders, there was an enticing option to purchase both wings, enabling a swift switch between them in just about 10 minutes, promising a versatile and thrilling flying experience. The BD-5 was a marvel of engineering, designed not only for ease of flight, but also for simplicity in assembly and ownership, creating a whirlwind of excitement in the aviation world. Constructed predominantly from fiberglass panels elegantly draped over a sturdy aluminium frame, the aircraft promised a dramatic reduction in build time, cutting it down to just a few hundred exhilarating hours. While the initial designs called for a bit of welding in the landing gear area, the innovative plan was to eliminate this need in the kit versions, ensuring that construction could be accomplished with standard tools and no need for specialized skills. But the allure of the BD-5 extended beyond its construction. The aircraft boasted an astonishing operational cost-effectiveness, delivering a staggering fuel efficiency of 38 miles per gallon. With wings that could be swiftly removed, the compact aircraft could be tucked away into a bespoke trailer, making it effortlessly towable by car. This meant that owners could store it in their own garages and transport it to any flat terrain for an impromptu takeoff, adding an enticing layer of versatility and adventure to the BD-5 experience. In November 1970, the aviation world buzzed with anticipation as Bede released an information booklet about the BD-5, setting the stage for a flurry of glowing magazine features. Science and Mechanics' October 1971 issue showcased the BD-5 on its cover, tantalizingly pricing it at $1,950. The article inside detailed the construction of the original prototype, showering praise on its ease of assembly. Popular Science followed suit in August 1973, featuring the aircraft once again, but this time listing it at $2,965, inclusive of the 40-horsepower engine. The BD-5, dubbed the miniature fighter, had successfully captured the imagination of the masses, sparking intense demand even before its wheels first left the ground. The fervour reached new heights on February 24, 1971, as the first $200 deposit was collected to reserve a spot in the kit line, setting a bold target shipping date of May 24, 1972. By August of that year, a staggering 800 deposits were secured. And this was even before the prototype had completed its high-speed taxi tests. By the close of 1971, over 4,300 orders were placed, propelling the BD-5 into the annals of history as one of the most popular general aircraft projects of the modern era, captivating the imagination and adventurous spirit of aviation enthusiasts around the world. The BD-5's flight testing phase was a whirlwind of innovation, challenges, and intense engineering. The prototype N500 BD soared for the first time on September 12, 1971, powered by a 36-horsepower Polaris Industries snowmobile engine. This marked 16 thrilling months since deposits were taken, stirring some unrest in the press due to the delay. The aircraft's stability was questionable with its original V-tail design, necessitating a swift and crucial redesign. Opting for an all-metal fuselage with hydroformed aircraft-grade aluminium alloy components, the team was able to make rapid modifications during testing. With orders pouring in, the decision proved economically sound, spreading the $30,000 tooling cost across a large number of units. By December 1971, new fuselage tooling was underway, resulting in a more streamlined nose compared to N500 BD's rounded front. Meanwhile, the team continued tweaking the empennage, eventually trading the V-tail for a more conventional and efficient design. The first of the new fuselage, N501BD, arrived in March 1972, fitted with a new Kieckhafer Aero Marine engine. However, its maiden flight was delayed until July 11, 1972, due to numerous small setbacks, revealing persistent pitch stability issues. The program's scale soon outgrew BD's capacity, leading him to hire Bert Rutan and Les Berven, freeing BD to focus on pressing business matters. The search for a reliable engine continued, amidst a series of technical challenges, including low stick forces and mixture issues leading to rough engine operation and 2 crash landings. As the team decided not to repair N501BD, they shifted focus to N502BD, which faced its own set of challenges, including severe vibration issues resolved only after months of expert intervention. However, from March 26, 1973, the test program progressed more smoothly, albeit with 2 additional emergency landings. By the end of the test program, the BD-5 had undergone monumental changes, affecting everything from the wings and canopy to the landing gear and tail design. The biggest transformation, however, was in the engine, with the original 40-horsepower model proving insufficient, necessitating a shift to a high-revving 2-stroke engine. Despite ongoing issues with rough running and high fuel consumption, the program paved the way for the jet-powered BD-5J and the unsuccessful BD-5S glider. BD also explored the possibility of FAA certification for the BD-5D as a production aircraft, signaling the end of the tumultuous yet groundbreaking test phase. By mid-1973, the BD-5's design was finalized, and production tooling was ready, though the aircraft was held up by engine delivery issues. BD, in a strategic move, decided to ship the aircraft kits first, with the engines to follow, allowing builders to start assembling their aircraft while waiting for the engine, expected to arrive by September 1973. Many builders embraced this option, though some received incomplete kits and plans. Originally, all 3 Hirth engines were available to the builders. However, due to the underwhelming performance of the 40-horsepower engine, BD later recommended the 70-horsepower model, developed in conjunction with Hirth, setting it as the new baseline. Over the 30 months since the initial deposits, prices had inflated, with the base price rising from $1,799 to $2,599, with the 55-horsepower Hirth engine. By 1974, engine deliveries were still scarce, though some began to trickle in early in the year. The situation took a turn for the worst when Hirth unexpectedly filed for bankruptcy after only 500 engines had been shipped. The BD-5 was once again without a suitable engine, leading BD to a Japanese Zenoa design, which unfortunately would not be certified for export until 1978. BD, ever innovative, devised a creative solution for training pilots on the new aircraft. By attaching an engineless BD-5 to the front of a pickup truck with a trapeze system, and linking the pilot's throttle control to the truck, pilots could safely fly the aircraft without risk. If any issues arose, the truck driver simply had to hit the brakes. This ingenious contraption was dubbed the trucker plane, earning Bede a US patent for his inventive approach to pilot training. After successfully delivering over 5,100 kits, shipments from Bede aircraft abruptly ceased as the company spiraled into bankruptcy, officially declared in 1979. Despite the looming financial turmoil, efforts on the BD-5D persisted for a period. Bankruptcy proceedings revealed that funds intended for kit production were misappropriated for various unrelated projects. Consequently, Bede agreed to a 10-year ban on accepting aircraft deposits under a consent decree with the FTC. The disruption left many kit owners in limbo, resulting in stored, abandoned, or resold kits. However, a resilient few, numbering in the hundreds, managed to complete their aircraft, improvising with diverse engines and modifications, facilitated by third-party designers and former Bede dealers. The building process proved far more difficult than initially advertised. Bede's projection of 600 to 800 assembly hours contrasted sharply with builders' actual experiences, some of which extended to an exhausting 3,500 hours. Challenges included adapting the airframe to alternative engines, given the unavailability of the original Hearth engines, and navigating the labour-intensive task of securing the all-metal panels. While Bede had marketed the BD-5 as a DIY project suitable for garage assembly, builders concurred that achieving a safe aircraft required adherence to proper construction techniques. Utilising meticulously arranged jigs for precise drilling and alignment emerged as a solution to this issue. The resultant chaos, marked by kits shipped with missing parts and general disarray, culminated in a flurry of kits being sold at drastically reduced prices. This fire sale, however, did present an opportunity for builders to complete their aircraft at a fraction of the cost. When Bede aircraft first rolled out their kits, they recommended the B-wings. Yet the earliest ones only included the short A-wings. Tragically, all 4 aircraft assembled with these wings crashed during their initial flights, resulting in 3 deaths. Of the initial 25 aircraft, built with both A and B wings, 14 crashed, resulting in 9 fatalities. The switch to B-wings didn't significantly improve the safety record, as numerous crashes were caused by engine failures during takeoff, attributed to a variety of engine types and persistent cooling issues. The BD-5's unique design meant an engine failure led to a sudden nose-up attitude, catching pilots off guard, leading to stalls and crashes. The abrupt stall characteristics of the original wing, manufacturing errors in some wing skins, and a narrow centre of gravity range further compounded these safety issues. As the Bede Aircraft Company faced its end, the BD-5 entered a period of uncertainty. However, over time, solutions to these problems began to surface, and various modifications improved the original design. The quest for a suitable engine eventually found answers in models like the Rotax 582 and Subaru EA81, among others. A BD-5A even set a speed record in its class with a Rotax 618UL engine. Harry Riblett, an airfoil designer, tackled the issue of the BD-5's sharp stall, introducing a wing root airfoil reprofile to soften the stall response without compromising performance. Meanwhile, fuselage stretch kits addressed the centre of gravity challenge. Several companies stepped up to assist builders in completing their kits, incorporating these modifications and offering support. Bede Microtechnologies and Altair Inc. are notable examples, providing a range of services and parts to BD-5 builders. Despite its tumultuous past, the Bede Aircraft Company has since been revived, exploring new designs, including a preliminary concept for a 2-seat BD-5 variant. The BD-5J, a jet variant of the BD-5, achieved fame, setting speed records and becoming a staple at airshows, even making a cameo in the James Bond film Octopussy. However, like its propeller-driven counterpart, the BD-5J had its share of tragedies, including fatal crashes and technical issues. In recent years, the BD-5J has found a role in national security as a cruise missile surrogate, with models like the Smart 1 used in training exercises. Despite these advancements and its recognition as the world's smallest jet, the BD-5J continues to be a thrilling yet challenging aircraft, captivating aviators and audiences alike.